Welcome everyone. In this video lecture, we will solve a diode based numerical which is from the Microelectronics circuits book. So the question is, in the circuit shown below, both the diodes have eta 1, but D1 has 10 times the junction area of D2. So in the question it is given D1 has 10 times the junction area of D2. It is given means what it means? Means if the saturation current of ISD2, I am writing ISD2 is say IS, okay, the junction, or we can say the saturation current ISD2 is IS, then the saturation current ISD1 should be 10 times of ISD2, or simply we can write 10 times of IS. This means the D1 has 10 times the junction area of D2. So the reverse saturation current ISD2 is say IS, okay, and the reverse saturation current of the diode D1 will be 10 times of IS, okay. Then what value V results? So this one is two current source. One I1 is 10 milliampere and I2 is 2 milliampere. So what should be the voltage? Okay. And to obtain the value of V of 50 millivolts, suppose we need a voltage of 50 millivolt, what current I2 will be? Okay, so first of all, what we can do in such a problem, so I1 is 10 milliampere. So what it means? 10 milliampere means 10 into 10 to the power minus 3. Means 10 to the power minus 3 means 0.01 ampere is flowing, okay, through this. So for example, I am saying this current is I2. This one is I2. So all current is going like this. So I am saying this current is I2. So this current will be our 0.01 minus I2. Simple Kirchhoff's current law. I1 is there, I2 is going in this path. So this current will be 0.01 minus I2. Okay. So this is clear. Now what can we can do? This for the voltage is V. So I am saying this voltage. This voltage is a VD1. So the entire voltage is nothing but simply our VD1 in this. Okay. So in this wire, the voltage is a VD1. Okay, so this voltage is also VD1. So now we can write the current equation in the ID1 and ID2. The current through ID1. So what we can write? The current equation through D1. Okay. The current equation through D1, that is our, I am saying ID1. I am saying this as a the ID1, okay, which is nothing but simply our I2, okay. So one can write ID1 equals to I2 because this one is I2, but we can write ISD1, the reverse saturation current of D1 diode, into EXP VD1 minus VD1, this voltage VD1 minus V because this one is a diode. Okay, this voltage is VD1 and this voltage is V. So VD1 minus V by eta VT. So but eta is already given 1. So it should be our simply VT. Okay. So this expression is somehow we can write as I2 equals to ISD1. ISD1 is 10 times of IS exp vd1 minus v by vt. Okay, say this was the equation number 1. Okay, I2 equation can write like 10 is. Okay, 10 times of is, because the junction area of d1 is 10 times the d2. So if d2 is means reverse saturation current is, so it should be just double. Okay, I'm highlighting this one. Means if the reverse saturation current of d2 is is, the reverse saturation current will be 10 times of is for diode d1. Okay, so now we have written the I2 expression. Okay, VD1, this voltage VD1 V. So VD1 minus V. Okay, we are just using the diode equation, simplified diode equation like IS EXP. Simply we can write VD by eta VT. Eta is 1. Okay, VD is now VD. This voltage is our VD. So VD1 minus V will be our, here the VD1 will be VD1 minus V. Okay, then it, so like that we can write. Similarly, we can write the current equation. The current equation through D2 becomes what? Okay, the current equation in this D2, that is our, we can write it ID2. Okay, the current ID2 is nothing but simply 0.01 minus I2, 10 milliampere minus I2. So this, then again you have to write the what, diode equation. So here simply we can write I SD2, reverse saturation current, into EXP. It should be VD1 by eta VT. So simply VT. Because for this one is our D1. Now for D2. D2, this voltage is VT1 and this one is grounded. Okay, 0 volt. So VD1 minus 0. So this one we can directly write. Okay, so one more line we can write 0.01 minus I2, because I2 is known to us. Okay, IS2 is simply our IS. ISD2 is IS. So we can write EXP VD1 by VT. Say this one is your equation 2. Now there are two equation. Okay, and two equation is there. Okay, so now we have to solve. So here VD1 by T is there, VD1 by VT is there. We have to find I2 we know. So what we can do, we can divide equation 1 by 2. Okay, here I am writing by dividing one equation 1 by 2, like that we can also write 1 by 2. Okay, so this one is I2. Okay, so simply I am writing I2 divided by 0.01 minus I2. Okay, one can write simply equation 1 like 10 is exp vd1 minus v by vt whole divided by is exp vd1 by vt. Okay, so here this is and is will be cancel out. Now one more line we have to write 0.01 minus I2 equals to 10 times. Okay, this one is 10 is there, then exp, one can write it vd1 minus v by vt minus vd1 by vt. Okay, Vd1 minus V by Vt minus, if we go this exponential will go up, minus Vd1 by Vt. So this will be our 10 times of exp, and this will be minus V by Vt. Okay, minus V by Vt we can simply write, because this portion and this portion if you solve, a minus b minus a, so this will be cancelled out, so this one is the expression. So now what we can do, one more line. Now see, only the v term is there and I2 term, I2 is known, so v, so we have to find the relationship between v and I to, we have to find v. Okay, so v, now we can easily find the value of v. Okay, so what we can do, we can write one more line, minus v by vt. Here is 10, so if it will go in this side, I2 times of 10, 0.1 minus I2, or we can write this one as a minus V by Vt, take the I2 by 10 times of 0.01 minus I2. Very simple, means initially we have to find this V. So Vd1 we have taken the unknown now, but this Vd1 will be cancelled out. Okay, so now our final expression for V equals to minus Vt ln I2 by 10 times of 0.01 minus I2. Okay, I am highlighting because this one is uh, final. V equals to minus Vt, known, all these things. Okay, now we know the thermal voltage. Vt is our thermal voltage. This one eta Vt, Vt is our thermal voltage. So Vt is our 25 millivolt. So now what we can do, Vt value is known to us 25 millivolt, or we can write it 0.025. Okay, Vt 0.025. I2 is also known to us 2 milliampere, 2 milliampere. So 2 milliamperes we can write. Okay, or simply 2 into 10 to the power minus 3 ampere. So now we have to find V, because in the question they are asking the, to obtain the value of V. Okay, what value of V result first, then after we have to find what value of V for 50 millivolt, what should be the current. First we have to find the V. So what we can do, the V equals to minus 0.025. This should be 2 into 10 power minus 3. This is minus 3 by 10, 0.01 minus 2 into 10 to power minus. Okay, clear? Means simply, because we have all the value like Vt and the I2 value. So if we solve this one, this should be our 2 into 10 to the power minus 3. Okay, and if we solve this one, 10 minus 0.01 and 0.002. So if we solve the whole term, it will come 0.08. Okay, the denominator part. So it should be 0.025 ln, we can write it 2 by 80. Okay, 10 to the power 3, or if it 2 double zero, okay, 10 to the power into okay, 2 by 80, clear. Then 2 by 40, 1 by 40, 1 by 40. So if we solve in calculator, it will nearly come 92.2 millivolt. Okay, if this simple calculation, the important thing is this expression. Okay, now this V is given, so first part is over. V will be 92.2 millivolt. For this one V will be 92.2 millivolt. Okay, now in the question they are asking, if V is given 50 millivolt, means expression is this: V equals to minus Vt ln I2 by 10 times of 0.01 minus I2. So if the V value is given 50 millivolt, so we have to find the I2. What I2 will be there? So what we have to do? Again, everything is given. So we have to find I2. So what we can write? Minus Vt ln I2 10 times of 0.01 minus I2 in bracket equals to 50 millivolt. So 50 into 10 to the power minus 3. Okay. So now from here we have to find the value of I2. So I2 can be easily find by simply we can write it. Okay, or one more line. Okay. I2 by 10 times of 0.01 minus I2 equals to minus 50 into 10 to the power minus 3 by Vt. Vt is 25 millivolt. Vt, or we can write 50 minus 50 into 10 to the power minus 3 by 25 millivolt, 10 to the power minus 3. So this should be minus 2. Okay, minus 2. So one can write I2. Okay, I'm solving. 10 times of 0.01 minus I2 and ln, so it should be e to the power minus 2. Okay, e to the power minus 2, or one can also write I2 equals to I2 equals to e to the minus 2 into 10 0.01 minus I2. Okay, I2 equals to this one. I2 equals to e to the minus 2 into 10 times of this minus I2. Okay, so if we solve this one, so I have already calculated. So if we solve this one, it will come around I2 value will be 5.75 milliampere. Okay, it can be easily solved. Okay, but the main thing is your expression, this expression that we have find out. Okay, so like that we can solve. So this one is a little bit tricky in the very first step, because D1 has a junction area of D2, so that thing we have to take care, means situation current of the diode D2 will be say Is, so the D1 will be 10 times of IS. So like that we can find. So first part we have find for I2 2 milliampere, the V value will be 92.2 milliampere. Now we have the expression between V and I2. V and I2 expression we have find. Okay, so we can find the value of I2. Okay, so V 50 millivolt, the I2 will be 5.75 millivolt. So this is all about this question. Okay, and this question is from Microelectronics circuit book. Okay, Microelectronics circuit book by Sid Smith. So thank you for watching this video.